So hello everyone, and today we will be seeing one of the problems from Geeks for Geeks, saying largest number in one swap. The problem is very simple, and they provide us with a string S. Return the lexicographically largest string that can be obtained by swapping at most one pair of the characters in S. So S is one of the string which is supposedly long, and we wanted to make it large, so with only one swap. So if I move 8 to the first place, then it would be 867, which is the bigger number than S, and that's how we can proceed. So and 333, it's no point in swapping because all the numbers are same. So that's the way we can do it. So how to solve this? How to solve this one is a good question. You can do two things. I have two solutions over here. One is the most common solution, is to find out the maximum within the string. Maximum within the string, which supposedly is not at the front. So you have something as 3, 4, 6, and then 9, and then 2. So I'm at starting position of this, and wait a second, here, and I traverse from this point to the ending, and within that I found out 9. So I get to know that 9 is the maximum number, and which when can be swapped with 3 can give us the maximum out of this number. So keeping 4, 6, rest of things aside, and this is a greedy approach to solve this, and which is acceptable, which is good, and which is the thing which you can find most common within the solution section as well. So this is not a very it's not a very hardcore example, or very rare to find, but we would be going ahead with one of the other solution in the mind is something like of sort. You might have heard about selection sort. So if you are unsure of that, then let me reiterate upon what selection sort is. So if you are given an array like this, selection sort, what it does is it finds out the minimum out of this array, and it puts it into the front, and it takes the next array. Now the minimum is set, the rest of array looks like this, and you go ahead, repeat the same process with the next, and same with the next. But now here we don't want it to sort it in the ascending order, but in the descending order, just with one step. So what we wanted to do is figure out max while we go ahead. So we figure out max, and then we go ahead and swap this one. Both are same, but in taking a different approach altogether. Now within this, I have string. So I'm using Java, and as you know that strings in Java are immutable. So I need to convert the string into character array so that I can do some operations upon this. So S is equal to str dot toChar array. Well, now I have converted it into a character array, so this is more easier to work with. I'm taking an iterator I, which would be working with s.length I++, and now here I assume that max index is I, and for int j is equal to I+1, and j is less than s.length and j++, because I wanted to move forward right onto the selected item as well. In this case, I would be doing a check if my max index, s of max index, is smaller than or equal to s of j, then hey, I wanted to swap this index, I wanted to consider this as a max index. So max index, remember I'm not swapping it right now, but I'll save it for later, because maybe maximum are further on to the length side. So I don't know, let this operation fulfill, and then I can see what max index is. So max index, I'll say j, and now here check that if I can swap max index or not. How I can know that hey, if in case s of max index should not be equal to s of I, in that case it would be just waste, because it would just repeat the same situation 3 and 3. We don't want to swap 3 and 3 again, so I'm just skipping this thing and I'm just checking only if they are not equal. If they are not equal, obviously s of max index is greater, and if it is greater, let's swap this. You know how to swap it. I just used temporary variable s of I, where s of I later would be s of I later would be s of max index, and s of max index would be t. In this way, swap operation is completed. I wanted to break the loop because it's the only one swap I can take, no more. And once the swap is completed, loop ends, and when the loop ends, I wanted to return new string of s. Let's compile this code for sample test cases, and it looks okay. Let's check it for rest of the test cases as well. Remember, this is not a usual greedy approach. It is a sort based approach with only one operation. And yeah, it has passed the rest of the test cases as well. Again, this question has been figured of this company NPCI, and the expected time complexity is O of n and O of 1. Well, we are using auxiliary array, but it's not an object creation. It is just a pointer to internal array. Since auxiliary, we didn't use any array. So yeah, this was about it, and topics regarding the string, data structures, and greedy. For more such content related to these topics or topics around them, around data structures, click the video on your right, and I will see you in the next one.